Welcome to Get Your FRQ On. This question is from 2006. It's question 5, and it is not calculator active. In the question stem, we are given a differential equation, dy dx is equal to 1 plus y over x, for all values of x and y such that x is not equal to 0. And in part A, we are asked to sketch the slope field for this differential equation. Like with other slope fields, we're just going to take the graph provided, input the coordinates for the indicated points, evaluate dy dx, and then sketch little line segments that match the slope that we get for that particular point. When we do that, we get a slope field that looks something like this. Now it's important to notice here that dy dx is undefined anywhere that x is equal to 0. So any solution curve we find for this can be defined on either the left of the y-axis or the right, but generally not both sides. So our domain for a solution here is most likely going to be restricted. In part B, we are given that f of x is a solution to this differential equation and f of negative 1 equals 1. And we are asked to find the function f that satisfies this and state its domain. All right, so first note that the differential equation dy dx is equal to 1 plus y over x is separable. So we can and must solve the differential equation using separation of variables. Most of the time when you see a separable differential equation in a free response question on the AB exam, you're expected to solve it using separation of variables, and you may fail to earn points if you don't. In fact, it's likely that you will not earn points if you don't. All right, so we set up our differential equation. We use separation of variables. Dy dx is equal to 1 plus y over x. So if I divide both sides by 1 plus y, I get dy over 1 plus y equals dx over x. And if we do the indefinite integral of both sides, we get dy over 1 plus y. The integral of dy over 1 plus y equals the integral of dx over x. Applying some calculus to both sides, we get the natural log of 1 plus y, the absolute value of 1 plus y, equals the natural log of x, plus c1. I'm calling this c1 because we're actually going to come up with a different value for c later that accounts for a couple of different things. Since both of these expressions are logarithmic, we can exponentiate both sides, and then we get the absolute value of 1 plus y equals e to the natural log of the absolute value of x plus that first constant, c1. Now, since y is going to be positive, 1 plus y is also going to be positive because we know for our particular solution, f of negative 1 is positive 1. So we know that we're on the top side of the x-axis. We're only going to be encountering values of y that are positive. So the absolute value of 1 plus y, we don't need the absolute value. All right, then we have equals e to the natural log of absolute value of x plus the c1. Now, if I split this using properties of exponents, we're going to get e to the c1 times e to the natural log of the absolute value of x. Now, e to the natural log of the absolute value of x should just be absolute value of x, and e to the c1 is just some other constant. Right? So that's where we're going to introduce just the letter c. There's no subscript here. It's not c1, it's not c2, it's just c. So we're getting close to solving for y. Given the initial condition that f of negative 1 is to equal positive 1, all right, we can use that to find out more about our function y, plug in negative 1 for x and positive 1 for y. We get 2 equals c times the absolute value of negative 1, which means c is just equal to 2. And now that I know c is equal to 2, I can write y as 1 plus y equals 2 times the absolute value of x, which is 2 times the absolute value of x minus 1 is equal to y. Now, oftentimes with a free response question like this, where you are supposed to find the function that is the particular solution to a differential equation, it is expected that you will solve it for y. So you would have to write y equals whatever, and instead of leaving it as like y plus 1 equals 2 times the absolute value of x, it's not incorrect mathematically, but you may be penalized for not doing that in a free response question. All right, now, since we are using x equals -1 to find the solution, remember, we can only be on either the left or right of the y-axis. We can't cross because this is undefined anywhere x is 0. Well, the x we're choosing is -1, so we must be on the left side of the y-axis, which means the domain for our solution here is going to be x is less than 0.